When we decided to teach the course on science and God that just concluded a couple of weeks ago, Mark was doing such a great job of that I kind of stepped back and let him do it because he was presenting some things that were just magnificent. And I'll refer to some of those today. But I said, Mark, would you like me to just sort of take this lecture a bit in beats? And Mark said, yeah, I'm pretty well sick of what I've been doing here for a while. And so, although I am speaking, Mark is going to chime in as pretty much anybody is, but he is behind a lot of the things that are going to be said tonight, so don't think that he's not important, because he really is. Now, Pastor Paul, who's my son, if you don't know that, always starts sermons with a joke. He seems to know better ones than I do, so I'm going to try a true story. When my three children were about 5, 6, and 7, and don't worry about the fact that we used to celebrate Christmas Eve at the Magic Type Machine. Because of the communication of siblings, we decided that it was time to have the talk about Santa Claus with the youngest. While the two older ones had gone down to the disco downstairs to dance together, we asked the younger girl to come talk with us. I said, we need to talk to you about Santa Claus. And she said, oh, I know about Santa Claus. He's dead. Me, why do you think that? She, well, he was an elf, wasn't he? Jolly old elf. So, well, in the Great War between the elves and the fairies, all the elves were killed. I then realized that my mythology was years behind theirs. And so that was the end of the Great Revelation. Now, this story is really true, but it makes a particular point that I want to talk about tonight. This was, for my daughter, a very good model of the facts she'd known, that were known to her. You know, she'd seen the presents, and she knew that there was something else going on. She'd figured out that it took a long time to get all those delivered to everybody in her. So she had this wonderful model that worked for her, fit all her observations. Well, we all think in models and verbal metaphors and figures of speech. Now, much of our ordinary language is made up of metaphors and similes, and those two figures of speech make an implicit or hidden comparison between two things that are unrelated, but share some contradictory or different objects, so that they share some resemblance of two contradictory but different objects. A closely related figure of speech is a simile, which is a comparison which typically contains the words as or like. For example, the entire 24th Psalm, the 23rd Psalm, 24th one too maybe, 23rd Psalm is a collection of metaphors, and many of the parables are similes. Heaven, the kingdom of heaven is like a treasure hidden in a field. That's a simile. The Lord is my shepherd, I shall not want. That's a metaphor. So, when interpreting the Bible and other theological work, we need to be aware of the use of figures of speech. Changes of meaning of words, differences in worldviews, and even changes in what various bodily organs are understood to do or to control. For example, the brain was not understood to be anything having to do with thinking or intention or emotion. This was as a man thinketh in his heart, is not an emotional concept, but one of intention or volition. That's what the heart was supposed to provide. The kidneys actually control emotions. That's really what they thought. There's some real validity in that observation sometimes. Well, most of our thought processes then, and our language, and our understanding of the world, or the universe around us is primarily a collection, even a superposition of various models, some of which have changed from time to time, from their origins until today. The other mistake we can easily make is the confusion of the model with the real thing. That's an easy step in logic that we sometimes make, and it leaves us with a dead Santa Claus. Now, I would suggest that now, why do you think that there is such a conflict for some people considering evolution and science? I would suggest that it springs from different conceptual models and the determination of some groups not to allow their own personal model to be challenged, changed, or even questioned. The Bible is full of examples of conflicts between some inspired person and a closely held model. Moses, for example, and the Egyptian priesthood, who, in the ancient world, the priests were not only the religious figures, but also primarily the scientific controllers of the government. The prophets in foreign lands were another group set. Jesus and the ruling Sanhedrin, Paul and the Grecian authorities. All of these times, sometimes this was the worldview that was being challenged, and sometimes it was just certain groups who wanted to maintain their power. Both of those things contribute to a lot of the conflict. Well, Mark Tapley did a marvelous job on comparing our own religious articles of faith with similarly closely held concepts, which are essentially articles of faith held by certain scientists. That is, members of both groups often hold very strong beliefs in certain models, which sometimes, maybe even often, do not hold up to new information. Here are some, next in the slide, we'll go to, there's another slide. What's my slide? Ah, there it is. That's amazing. I've been trying to make our elevators in the towers be able to remember what I wanted to say. What floor I wanted to get off. They didn't want to do that. But here are some dates of some people who have strongly influenced our accepted models and worldview. Let me briefly talk about a few of these. First is King David. It's a strange one to put first, and I've got a reason to have him there, and we'll get back to him in a minute. The next one I would like to mention is Aristotle. Aristotle lived in the 300 BC region. Now, Aristotle is important because he put together a series of models of the ancient world, the heavens, and everything else. And that model lasted for nearly 2,000 years. So, the other thing is that Aristotle had a nice student named Alexander the Great, who went about conquering the whole world and therefore spread Grecian knowledge throughout the entire Mideast. So between Aristotle and Alexander the Great, most of what we read in the Bible has a connection to Aristotle's model of the universe. And he had a model for nearly everything. He was a broad thinker. Now the next one, who I think is important in our system, is Jesus. Not go into detail there. But about in the 1200s, after Jesus. That's CE. That's the new thing you're supposed to use rather than BC and AC and all. But anyway, Thomas Aquinas was a theologian and a philosopher and a bishop, I believe, at the time. And he was commissioned, or just did it himself, of trying to make the models of Aristotle agree with the Catholic position, the church's position at that time. And he did a good job. And so much of what the church used and thought about was Alexander's theories as redefined by Thomas Aquinas. Now notice the next couple of folks that are in the list are Martin Luther and John Calvin. They are not too far different from those, but notice that they precede Galileo and Kepler, who thought, well, maybe the world isn't the center of the universe, but maybe there's another way to think about that. And then the next thing is the King James translation. So when you get to the King James translation, which every new translation talks about just a revision of that, but you're talking about a translation, you're talking about a worldview, you're talking about concepts and world models that are pre-Newton. Okay. John Calvin and Martin Luther were all in a situation that we really would not understand their worldview at all if we were looking at the universe. And then finally there's a gentleman named James Ussher. He published in about 1650 a chronology taken out of the Old Testament. Most biblical scholars question that chronology, but it's been printed in many different commentaries, and so it's become part of the worldview of many of us. What he did is he went back to the Old Testament and he figured out the year here and the year that, and how long Methuselah lived and when Adam was born. And he actually specified a day and hour in which the universe was created, in which the world was created. So it turns out that Archbishop James Ussher really influenced a lot of the thinking that has gone on since about 1650. Then the next was a fellow by the name of Charles Darwin. And he lived between 1809 and 1859. And under him, The Origin of the Species was published. He had gone on a trip, looked at really great many changes that he saw in different animals in different positions, and he felt that there was a time in which different animals changed their characteristics depending upon the environment in which they found themselves. Now, there are some problems, and we'll talk about that, but after that, there was a great deal of turmoil that existed in some religious circles about what Darwin had said. And so we'll talk about why in a little bit. But notice that two other things that we're going to talk about today are important in our own worldview. And that is the concept of genes was discovered in about 1940. And the structure of DNA is fairly recent. We're talking about 1968. So it's a very modern thing that we're looking at when we talk about science and religion. And now, I will note also, I'll talk about King David in a minute. Okay? Let's go to the next slide. Mark Tapley did, like I say, a marvelous job of comparing our own religious articles of faith
with some similar closely held concepts, which are essentially articles of faith of scientists. Now, here are some dates that some people who have been strongly influenced with. Some dates of some people who have strongly influenced that. Now, let's look at some strongly verified information, which may or may not fit our own religious articles of faith. And that is this table right here. And somebody said, well, what is the scale on the left-hand side? Well, the scale on the left-hand side here is the years from today, or years back from today, in billions of years. Okay? So we're talking about a scale of time that runs a little bit longer than 13 billion years. The Hebrews had no concept and didn't even have a word for something greater than 1,000. Okay? And indeed, one of the things, there was one word that's occasionally used in the Bible, which is myriad, and that indicates tens of thousands, maybe 100,000, but nothing close to 1,000,000. And 1,000,000,000 is 1,000 times more than 1,000,000. So you're talking about a huge scale of time here that is practically unimaginable. In fact, the only time that I know of that something bigger than billions are used is adding up the national debt. Okay? And that's 1,000 times bigger than 1,000,000,000. Okay? So when you see Congress passing a new debt limit on the order of several tens or hundreds of trillions of dollars, know that that is a lot of dollars. And a trillion, and a billion years is a long time, incredibly long. It's not really imaginable because we don't have any kind of personal experience with that kind of timeline. King David, for example, I said he was coming back. He reigned about 1,000 years before Christ. And so when the Jews talk about a long time, they talk in terms of thousands of years. You find that in Revelation. You find that in lots of other places. And that's about the longest time period that they ever even considered. There's one other relationship which time times and half a time is used, and that's about 1,260. So you're talking about people that had sheep, and if they had 1,000 sheep, that was just more than you can imagine. If they had 1,000 soldiers, you didn't want to go up against them because they all had spears and swords and chariots, and so that was a big thing. And that kind of money and that kind of power and that number of people was just amazing. And so when we talk about millions, that's beyond anything that ever came to count. The first thing we're going to talk about is the things that go into making you and me. And so, what I'm going to do here, Mark Tapley, in one of our classes, was discussing a video which showed a young lady lying in the grass, and it proceeded out from her as far as we could see in the universe, as far as we understood the universe could come. And then it went back in to her lying in the grass, and then it proceeded into her eyeballs, and then into the structure of atoms, and then the structure of nuclei, and finally the structure of quarks. All of it, well, not the structure of quarks, but that was the limit. But I'm not going to go I'm not going to go in, but I am going to go out, and so I'm going to reorder this order, starting at the bottom here and working back up as things that contribute to making us, or you, if you like. What does it need? What things are required? Well, the first thing you need is a universe. And a universe has space and time and energy in it. And 13.7 billion years ago, something remarkable happened. A universe was created, and we do not know how or why or from what. It just was all of a sudden present. And it's not, and then there was an enormous cosmic expansion that took place, and that really led to the rest of the things being possible. Now, it's not the fact that the universe expanded in space. There wasn't space or time without the universe. The universe, when the universe was created, so were space and time. It didn't expand into a space or a time that already existed. It just expanded space and time. So we live in a universe that didn't even have space or time in it before it was created. And we don't know exactly what happened there, but we do know that something really remarkable happened, is that not only after it was created, then there was an enormous expansion that continues on, essentially. But that instantaneous, huge expansion changed all the rest of the stuff that contributes to you and me. For example, you've got a spongy structure of galaxies that existed. And those galaxies were created about 30 billion years ago. The density was not too high, because if it had been too high, the universe would have collapsed. But it was not too low to prevent galaxies from condensing from stars. So the distant galaxies that we find were really quite early, which was just after 13 billion years, 13.7 years ago. There's some galaxies that are created. And those galaxies were scattered at the right intervals, not too close, but not close enough to have some collisions. One of them eventually was the Milky Way. And the Milky Way is our galaxy. We're part of the Milky Way. It's a stable galaxy. It's not one of the hyperactive galaxies or irregular galaxies where stars and planets cannot survive, but it's a highly regular one. Waves sweeping through it kick off the formation of massive stars periodically. We've all seen those pictures from NASA in which you have star fields and things of that sort, and giant things that look like filaments in which, when you look closely, are new stars being created. And that occurs in our own galaxy. And that's part of the thing that makes us. Stars came into there were some about in our star system on the order of 4.5 light years away. 4.5 light years is how far light can travel, or a light year is how far light travels in 1 year. And so it's not a measure of time, it's a measure of distance. And so those galaxies, the stars that we see are about 4.5 light years away. Not that they were created at that time, but that's how long it takes the light to get to us. And those stars are sprinkled close enough to light the nights, but far away to prevent collisions or close passes by our solar system. The galactic core, on the other hand, has stars much closer together. And so consequently, we wouldn't survive in that sort of thing. Now when you get to our own solar system, the farthest thing that we know about in that particular thing is called the Kuiper belt. It's way out at the edge of our solar system. And it's a bottomless supply of light gases and water-building blocks. It's disturbed and scattered by Neptune, the planet, and it delivers water to the inner solar system of which we are a part. We're part of the inner solar system. And it's at a rate to replace losses on Earth, which will, by the way, the water will be used later for a specific purpose. It's important to have water come by, and it has to come from someplace, and it seems to come from the Kuiper belt. Closer to us are the gas planetary giants like Jupiter and Saturn. These are things that are not of the same kind of core that we have. A bottomless, the gas planetary giants, and then take note of water. There's a temperate zone for water that the Earth exists in that is not too hot, so the water doesn't all evaporate, and it's not too cold, so the water doesn't all freeze out. It's just a small space in which, in our solar system, in which things that have water can exist. Otherwise, it all boils off, or it all blows away, or it doesn't ever come. So it's an important characteristic of where we're located, so that there's going to be water. The meteors for the Kuiper belt are fenced in by Mars, permitting only a few impacts to slip by. But probably there was one huge one to knock the stuff out of our future planet home here that will become the moon, our sister planet. Now the moon is where it has got a particular job to do for us. If it weren't there, our orbit would not be stabilized. But the moon stabilizes the orbit, stabilizes the variations that we have in the orientation of the Earth, and it provides tides to flush and renew the pools that are of water, and to provide light at night as a stepping stone to the universe, perhaps. So the next thing that we want to look at is something about 4.5 billion years ago, which is called a little tiny bit, it's hard to read on the screen, but that says water right there. It's about, the Earth didn't have any water onto it until about 4.5 billion years ago. Now, the presence of liquid water on the surface and in permanent reservoirs, fresh and salt, provides solvents in which our chemistry takes place. Earth is the right temperature for that to happen. Mountains are something else. Vertical relief, which lets the water evaporate and condense and run down again. And land, which provides tide pools in which life emerges to see the stars and to be able to light fires and to fly. Earth is tectonically active. There are earthquakes that go on. And finally, there is a magnetic field that exists from the core of the Earth itself, and that magnetic field protects us. Protects the water and the atmosphere and all of the things that are available to us. If we didn't have that magnetic field, lots of things, bad things would happen, but it protects us. So all of that is required to make a U. Now, about 3.5 billion years ago, life either occurred or arrived on the Earth. 3.5 billion years ago, interestingly enough, here is called the earliest life. And one of the surprising things is how soon after it was the earth solidified that life arrived or occurred on the earth. When I say two things, that we don't really know whether it arrived from someplace else or whether it occurred first on earth. But it's a very strange phenomenon. And just to say, well, it came from someplace else doesn't do anything but move it further out. We don't know where life originated, but on earth, we know that it began to be on earth about 4.5 billion years ago. Now, probably we should go to the next slide, because this is the diagram of a cell. All life is cellular. We do not know of anything that is not cellular that we would call alive. And that's some very primitive stuff. It's like pond scum. And all the things that have any characteristic of living soul, of living things, are made out of cells. And all life is made of that from cells. And then in the cell are chromosomes. You've heard of those. Those are the things that they're molecules, every one of which encodes more information than the Library of Congress. And interestingly enough, the chromosomal structure is only visible when they are combining. Other than that, it's too small to see with a light microscope. But we can now see things with different kinds of, quote, microscopes, unquote. We don't see them, but we can see what has happened to them much further. But in that is DNA. And the DNA is this molecule on the right, interestingly enough, made out of 4 different kinds of organic compounds. And just 4. But it's the so-called double helix. It's infinitely extendable structure that encodes information efficiently and, interestingly enough, reproducibly enough to transfer it from one cell to every cell in our body. So the DNA exists in all the cells and is transferable. Life on Earth then starts in water. It learns to use hydrogen, H2O, as an energy source. Early life learned to use the hydrogen from the H2O as energy, and then it dumped enough oxygen into the atmosphere for our ancestor animals to become air breathers. If it hadn't started in the water, if it hadn't changed form so that it used, or it didn't change form, but it used the water molecule as a source of hydrogen for energy, and then oxygen is released into the atmosphere, and then all of a sudden life is available out of the water. Now there's oceans too, that's important too. Oceans don't have not too little water and not too much water, just about 70% of the surface. And so that there's room for tundra and deserts and jungles and to challenge life and to develop diversity. Earth is diverse. One of the things, for example, is that there is weather. You get cold and warm and dry and rain and hurricanes, as we know, and ice caps. The Earth's climate is very dynamic and very robust. And then there was something else that happened. And one of those things was an enormous strike by a meteorite which essentially changed the characters of life's form from giants, dinosaurs, to smaller things. The dinosaurs didn't exist past that time, but rather small things began to be possible, so that it turns out that intelligence became the dominant survival characteristic rather than simply size and strength. So all of those things are contained in what makes us, makes you, makes us possible. Now, let's take a look at what happens. The DNA can come apart and go into a part of the cell called a ribosome. And when it does, then it can make more DNA and form amino acid chains in the ribosome part of the cell. Once you start talking about life, there's a great deal we don't know, at least not, the least of which is not how it got going in the first place. In about 1953, a young man, Stanley Miller, who was a graduate student at the University of Chicago, took 2 flasks containing a little water to represent primal ocean, the other holding a mixture of methane, ammonia, and hydrogen sulfide gases to represent Earth's early atmosphere, and connected them with rubber tubes and introduced some electrical sparks as a stand-in for lightning. After a few days, the water in the flasks had turned green and yellow in a hearty broth of amino acids, fatty acids, and sugars, and other organic compounds. As time has shown, it wasn't nearly so simple. Despite a century of further study, we are no really nearer to synthesizing life today than we were in 1953. And we're further away from thinking we can. Creating amino acids is something that happens. It's not really the problem. The problem is proteins. Proteins are what you get when you string amino acids together, and you need a lot of them. No one really knows, but there may be as many as 1 million types of protein in the human body, and each one is a little miracle in itself. Now, we're not talking about several 100,000 types of proteins, perhaps 1 million, and each, as far as we know, is vital to the maintenance of a sound and happy us. We take lots of different kinds of proteins. So we have a paradoxical situation. Proteins can't even exist without the DNA molecule. Now, let's go to another slide. Proteins can't exist without the DNA molecule. And what happens is the DNA molecule then is able to split up and make more amino acids and more proteins. The bottom line is that life is, so we have a paradoxical situation. Proteins can't exist without the DNA, and DNA has no purpose without the proteins. We are to assume that they arose simultaneously, the purpose of supporting each other. If so, that's a really surprising result. The bottom line is that life is amazing and gratifying and perhaps even miraculous, but it's hardly impossible because we repeatedly attest with our own modest existences. So life is a spectacular thing that happens, but we're all part of it. Now, one of the biggest surprises in this earth sciences was in recent decades that the discovery of just how early Earth's history of life, Earth's history, life arose. Well, it turns out it arose about, I've got the number here somewhere, about 3.85 billion years ago. Now that's stunningly early because the Earth's surface didn't become solid until about 3.9 billion years. So once the Earth's surface became solid, in a short length of just a few billion years, all of a sudden we've got life, forms of life that existed. Well, let me show you one of the things that we get out of those forms of life. Let's go to the next slide. Thank you. Here is two different sets of chromosomes. The one on top is the human chromosome. The bottom one is the chimpanzee chromosome. Notice there is the enormous similarity between the human chromosome and the chimpanzee chromosome. What's the difference? Well, it looks like that the two on the far left-hand side of the chimpanzees joined together to make a different kind of chromosome for humans. So there is the difference between, you may not be a monkey's uncle, but you've got something pretty close right there. All right. So, God's instruction manual to form living forms comes in the form of amino acids, proteins, chromosomes, etc., etc. It's all a very complicated structure. Now, Darwin's concept of evolution had a couple of real problems. The first one was an evidence problem. There were substantial examples of slight changes of some species in particular, called the survival of the fittest, but there were no transitional species. Well, we have some of the puppets down here. Okay, there's a duck and then a transitional species and then a duck-billed platypus, or vice versa. Nobody knows for exactly which. And that may not be a particular, nobody has really looked at the chromosomes of a duck and a duck-billed platypus. I do not know exactly if that may just be a nice model of what's going on. But there weren't transitional species. But it's exceedingly difficult to become a fossil. To become a fossil, you have to die at a particular time in a particular place where you won't decay. Like you have to be in the right kind of mud. And you have to undergo very little disturbance while your body parts are changed chemically. So that transitional species have not been discovered. As time went on, however, after Darwin had published his work, it turns out that that problem was remedied. There are transitional species that are occurred in the fossil record. Now, the second problem was when Darwin's model was published, it had no mechanism to explain it. There was nothing that explained why there were different changes of the species. Well, that was solved in the discovery of chromosomes and DNA, etc., etc., and that remedied that problem. So the Darwinian model of change and evolution does not have those losses now, or those problems now. It's a pretty good model. Now there's a recent form of creationism called the young Earth theory. Young Earth creationism postulates that God had changed all the nuclear decay rates, the photon red shifts, all other observable indicators of the incredible antiquity of the Earth and the universe to make it appear that all the Earth and the universe occurred in a few thousand years. Now this image of God as a cosmic trickster seems to be the ultimate admission of defeat for the creationist perspective by attacking the fundamental elements of virtually every branch of science. It widens the chasm between science and the spiritual world. So, this page is in backwards. It's not science that suffers the most here from early creationism. The young earth creationism does even more damage to faith by demanding that faith in God requires the assent to fundamentally flawed claims about the natural world and a totally unbiblical view of God. Young people brought up in houses with churches that insist on creationism sooner or later encounter the overwhelming scientific evidence in favor of an ancient universe and the relatedness of all human things through the process of evolution. What a terrible choice they face. To adhere to the faith of their childhood, they are required to reject a broad and rigorous body of scientific data presented with no other alternative than creationism. Is it any wonder that many of these young people turn away from faith, concluding that they simply cannot believe in a God who would ask them to reject what science has so compellingly taught us about the natural world and God's universe? Because, after all, the heavens declare the glory of God, and the earth showeth his handiwork. It's really pretty fancy handiwork, as you got to admit. Now, what I believe is that, well, first place, if the Bible isn't an adequate representation of how and when all things in heaven and earth were created, then what is it? I would say it is a careful and responsible collection by careful and responsible people of many types of literature written at many times and many different situations to many groups of people. Those people had different understandings of anatomy, of the world and the universe, and even of numbers. You may not be aware, but the number 0 didn't occur in any kind of calculation or description until in the Middle Ages. There just wasn't a 0 as a number. So that was an amazing discovery. You can do all sorts of things with zeros. You can make trillions of dollars. So, but to understand that, those people with different understanding of anatomy, the world, the universe, and even numbers had to be written in a form which their readers, the original readers, could understand. But that literature told of the interaction of the Creator and the creature made in their image. It shows many situations and many responses, nearly all of which have an ethical impact. Long ago, God spoke to our ancestors in many and various ways by the prophets, but in these last days, He has spoken to us by a Son. Well, I have dumped upon you a huge meal of information. But I want to give you something, a tasty mint to chew on before you go home. This is a strange mint that I'm going to introduce. Let's look at the next slide. Remember I mentioned Aristotle? He was a great observer. And one of the things Aristotle observed was that there was a difference between inanimate or not inanimate, but there were a difference between living things and things that didn't live. Now, Aristotle believed that everything was made in the earth was made of air, earth, fire, and water. And they had different characteristics. Air and fire went up, water and earth went down toward the center of the earth. And we are all essentially Aristotelian in our concepts. I mean, it doesn't really surprise you that, for example, that, heavy things drop faster than light things, unless you've got a good vacuum tube, right? So we're Aristotelians in our looking at the world, not carefully, and until you've had first-year physics. But he also observed lots of things. He talked about social structures, and he talked about governments, and he talked about, but one of the things he looked at was living creatures and living things, and he decided that there were essentially 3 different kinds of living creatures. There was a vegetative soul. Oh, a soul. That was Aristotle's, that's our translation of his word, which is psyche. Okay? And he said there was a vegetative psyche, which plants had. They can reproduce and they can grow. But there was an animal psyche, which had a sensitive soul, and it had mobility and growth connected to it. But then there were humans who had a sensitivity soul, who had thought processes and reflections. Now, the little mint that I want you to chew on is people spent decades and years and fortunes and lots of energy in trying to measure the weight of a soul. They would get somebody about to die and measure the weight and see if that changed when he died, because the soul left him. I would tell you that in the translations that we have in the Bible, the word that Aristotle used is psyche, and that is practically the entire definition of soul. So I'll let you just chew the tasty mint of that particular model. I'm not sure I know where that leads you. I'm not sure where it leads me. But it led Aristotle to be a pretty good guy, I think. Let me let you look at the next slide, which is in your booklet, which talks about references for this particular lecture. And I will tell you that I shamelessly copied, used. What do you do when you take when you plagiarize? Many different sources. But it was, I must admit that sometimes it got even more shameless than I like. And I'm pretty hard to shame. But one of the things that I did was I took Mark Tapley's introduction to a particular YouTube that he had shown us and rearranged it and used it blatantly. Now the graphical timelines and other things came from articles in Wikipedia, the free encyclopedia. If you're not familiar with Wikipedia, you need to go and look it up. There's practically one thing, it's a wonderful encyclopedia, and it's you don't have to have 18 feet of bookshelf to keep it on. And if you want to go from one particular thing to something else, you don't have to change volumes, okay? So if you're not using Wikipedia for your information, you need to think about putting it in that thing. There are two books that I used, again, shamelessly. And one of them is by Bill Bryson, which is called A Short History of Nearly Everything. It's exhausting. Okay. It is, considering all the things he covered, it is a short history, but there's a lot of information in this book. The other one is a book that I found to be remarkably interesting called The Language of God, and it's really a review of pretty much what we've said today. So if you're interested in referencing anything, take a look at those two. I've also included in there a discussion question. Dave asked me to write 2 or 3 or 4 to 5 discussion questions, but I decided one was enough, and I shamelessly took this one from The Language of God. That in this modern era of cosmology, evolution, and the human genome, is there still a possibility of a richly satisfying harmony between the scientific and spiritual worldviews? What view on the integration of science and religion did you have before the lecture, and how would you answer that question now? So, but there's one other thing that I didn't say. I think I didn't say it. Well, I should have said it. And that is what I believe. What I believe is God is the creator, but evolution of our universe and of life forms is at least one of his methods. In our survey, notice the number of times we said, we don't know, we don't understand, we're not sure how that happened. There are some very eminent scientists who believe that the physical world and the laws of nature, when we know all about them, will explain all. I believe there is more to life in God and his creation than the laws of nature. Belief in our Creator and faith in his methods, I believe, is a better conclusion. So, now you've had a parable, a life sentence, a couple of discussion questions, and it's time for me to quit. Thank you. I'd say I'd take a few questions, but I really wouldn't.
Do you mind if I talk for a minute?
He can't hear you.
Maybe you don't know.
Ah, good. Sure, please do.
So I have a short story and a question. I want to add the discussion questions. And people that were in the science and religion class probably already heard the story, so just sit there and smile and look quiet. Rudy gave you a huge information dump. It was wonderful. He talked to you about biology, astronomy, cosmology, and big numbers. And I'm going to take the easiest one of those, big numbers, and try and apply what he said to you. He told you that M, and I'm going to use the letter M, that's an anachronism, it's a Roman numeral, but it represents the biggest number that was available to the writers of Genesis when they were writing that story. And he also told you the age of the earth, 4.5 billion years. So I'm going to try and write on my phone here that age of the earth in years using the symbol that was available to the people that were writing Genesis and to their readers. And I'm going to start off writing M's. 3, 4, 5, and I'm going about 1 M per second. I could go a little bit faster, but I couldn't go that fast if I were carving M's into stone tablets or pressing them into clay tablets or even beating them on papyrus. And I'm still writing that number. Are there any guesses to how long it'll take me to finish writing the age of the earth using the biggest number that the Hebrews had? 3 minutes? 5 minutes? Any guesses?
10 minutes.
How long?
M.
M? Longer even than that. 52 days. Calvin would miss 7 sermons if he sat there in rapt attention watching me write that number. And when we finished at the next sermon, I would probably fall asleep and sleep through one of Calvin's sermons, and I don't want to do that, so I'm not going to finish writing that number. But, so that's the story. If you're trying to write the age of the earth to someone that could read it 2,000 years before Christ, that's how long it would take to write that number down. That's how long it would take to read that number. So my question, another discussion question, suppose you were writing Genesis. You were divinely inspired. You knew everything about numbers. You knew exactly what a billion was. You knew everything about biology and DNA. You knew everything about cosmology. You knew everything about astronomy. And you're writing the story not just so the tax collectors who would understand big numbers could read that story, but also so the fishermen and the shepherds and the carpenters could read that story. How would you write that story? That's the question.
Good question. Thank you both. Thank you, Professor. Thank you, Doc. I appreciate your great wisdom. You know, this subject is always, in some ways, unfortunately, split communities and congregations and, you know, creationism and, you know, is Genesis really true and how did, you know, all that stuff. When really, and especially the way you described it, Genesis is just as true if you see it through a scientist's mind as if you see it in another way. You know, I mean, that's the way I look at it. And actually, when you look at Genesis, what does it really say? It says that God created the world. It didn't say how he did it. It just said he created it. And he created, you know, it says he created it in 7 days. Well, but we also know that when it comes to numbers, what are numbers in the Bible? You know, I mean, they use all types of numbers in the Bible, and most of them are symbolic. And when you look at 7 days, could it have been 7 billion years? Could it have been 7? Yeah, sure, God could have created the world in 7 days. He's God, okay? But obviously, he had a different plan. And, you know, what did you say? How old is it? 4.5 billion years? Okay. Well,
Long enough to get it right?
but long enough to get it right. And then long enough for the humans to screw it up. but, you know, that's the way I've always looked at the book of Genesis and creation. I've never had any problem. And I'm a fairly conservative guy biblically. I've never had a problem with understanding how the world has been developed and created over billions of years, and how mankind just sort of came in there at what stage? What was it, 3.5 or?
Life is about 3.5.
Yeah, 3.5 billion. I've never had a problem with that. I don't know if any of you guys have, but I've never really had that issue at all. And I don't know, and I don't understand how anyone could think that a scientist, you know, can't believe in God. You know, like I was telling Mark, Einstein, I can't remember the name of the book, but Einstein wrote a book about his, how he came to believe in God. And the basics of his was that as the more he studied, the more he realized he didn't know. And the more he studied the universe and how intricately it came together, the more he realized there had to have been something behind it all that created it. You know, and that's why he believed in God. You know, and I think there's a lot of truth in that. You were going to have a question?
Yeah, just another yardstick.
Yes, sir.
Question.